Today we're going to talk about some properties of numbers and do a little bit of review. So, first question we're going to ask is, does 5 plus 6 equal 6 plus 5? And the answer is yes, 11 is 11. So, therefore, any two variables can be switched in order when we're adding. It's not going to change the answer. The same thing with multiplying. 6 times 8 is 48. 8 times 6 is also 48. So, if we have two variables, the order doesn't matter if we're multiplying. So that's what we're going to write, that order doesn't matter. When multiplying or adding. So this is what we call the commutative property. So if we look at the next problem, if I do 2 plus 3, I get 5, and 5 plus 4 is 9. 3 plus 4 is 7, 7 plus 2 is 9. And it's going to be the same thing if we multiply. Whatever I get times A is going to be the same thing as whatever I get times C. So it doesn't matter how we group. So grouping doesn't matter when we add or subtract. Or not subtract, excuse me, multiply. And this is what we call the associative property. So just to review our algebraic expressions, we haven't done them for a little while. When we say 4 times, that means 4 times. And if you see sum of, you have to draw parentheses with an addition sign. You're taking the sum of A and B. Then increase means to add. You're increasing by twice, that means 2 times. There's the sum of again, so parentheses with a plus. And you're adding A and 2B. So if you want to clean that up a little bit, it's going to look like 4 times A plus B plus 2 times A plus 2B. And it says you're supposed to simplify, so we're going to go ahead and do that. And you're going to distribute. So my like terms are going to be 4B and 4B, and then 2A and 4A. So this is something that you're definitely going to see on a quiz or a test. All right, move on to number 7, 5 times. When I see difference of, I put parentheses with a subtraction symbol. And I'm subtracting Q squared and R. And then it says plus 8 times sum of 3Q and 2R. So we're going to take this 5 and we're going to distribute to get 5Q squared minus 5R. And then we're going to distribute this 8 to get 24Q plus 16R. And my only like terms are negative 5 and 16. So my final answer is going to be 5Q squared plus 11R plus 24Q. Remember, you can't combine Q and Q squared because they're not the same exponent, so they are not like terms. All right, so you guys have all seen a number line before, and just as a reminder, there are infinite amount of numbers on a number line. There's two main types of what we call real numbers that you need to know, and that is rational and irrational. So a rational number can be expressed as a ratio or a fraction, which means all the decimal versions of rational numbers we get are going to be repeating. Or they're going to terminate. Irrational is the opposite. So irrationals are the really ugly numbers that we don't like because they're very annoying to work with. They never end. And they have no pattern. So some examples of rational numbers could be whole numbers. They could be square roots of perfect squares. They could be never-ending decimals that have a pattern. So maybe like 4, 1, 5, 6, 4, 1, 5, 6, ... All fractions are rational, so 3 1/4 is a rational number, 2/5 or 2/7 is a rational number. You sometimes see things like this. That means 2 repeating. And then irrationals, the most famous is pi, which I'm sure many of you know. Square roots of numbers that are not perfect squares, like 11. You could just make your own up. You could do like 8.9137 ... So you can make as many as you want. Make sure that you have the ... here, because that indicates going on forever and having no pattern, as we can see. So number 1 is a fraction, so it's automatically rational. Number 2, 20 is not going to work out to a perfect square, so that is definitely irrational. Number 3, I don't even care about this 2. I see pi, and that right away makes it irrational. All whole numbers are rationals. The square root of 100 is 10, so that's rational. And even though this looks like 3725, there's no pattern, it does terminate, so it is rational. Just as a reminder, when we put numbers in order on the number line, some things you might already have an idea of where they go, but it always helps if you turn each number into a decimal. So -2/3 is the same thing as -2 divided by 3, and that's going to be 0.6 repeating. So I'm just going to round it to 67. If you type square root in your calculator, so that would be the second button, and then you hit that little button, the x squared button, it's going to say about -1.41. This is 1.4 repeating, so I'll just write 44. We should all know that pi is 3.14 approximately. 0.25 is just 0.25. 1/3 is going to be 0.3 repeating, so I'll write 0.33. And then the square root of 10, I don't know that off the top of my head, so let's find out. It's about 3.16, so it's a little bit more than pi. So basically just read this as money, and we put in order on the number line. So I always look for the biggest negative number, so -1.41 would normally be bigger than 67, so it's going to come first in the negatives. And that was really -√2. And then I cross it out. The only other negative number is going to come next, so that was 2/3. I have $1, $3, 25 cents, 33 cents, so it looks like 25 cents is coming next. $1, $3, 33 cents, that's going to come next, so that is 1/3. And then I have $1, $3, 14, 3/16, so it looks like 1.4 repeating comes next, followed by pi, and finally √10. This is a reminder on how to graph these inequality symbols. So to show numbers that are greater than -2, you put a -2 on your number line. Draw an open circle to show that it cannot equal, it's strictly greater than, and then you point towards the direction that's greater. Number 9, you're going to write 4/3. So I want values that are less than or equal to that, so you're going to put a solid dot to symbolize could be equal to, and then you're going to draw an arrow pointing to the less than direction. And finally, number 10, if you have y equals something, this one's really easy. You just write the number and then you draw a solid dot on that spot.